Hey everyone, in this video I will show you how to create an analog clock mechanics similar to the one I used in my game. So without further ado, let's get started. Okay, so I have already imported a 3D model from Blender to Godot. As you can see, the clock hands are not correctly aligned with the rotation. So I will just reparent to a new node 3D. Here I will set the minute hands rotation to point towards 12 o'clock. And also to the seconds hand. So in the parents node we can see its rotation is set to 0 by default. Let's add some directional light and world environment just to see in the output. And also add a camera. Set the camera so that it can capture our clock. I will hide the camera. It will still render the output through camera. As we can see, it is still rendering the output through the camera 3D node. So now let's just add a script to our main node and delete the template code. Create variable for our clock hands. Now let's call our function process. But first, let's create one more variable called second completed, which will be of type boolean and set it to false by default. We will use this variable to call a function for every second. Let's create a timer and set the timeout to 1 second. After every 1 second, it will call a function named increase second. So let's create our function here. So in this function, we want our seconds hand to be rotated at a certain degree every second. So let's calculate. So let's calculate 360 degree divided by 60 seconds is equal to 6 degrees. So our seconds hand will rotate 6 degree. So let's create our seconds degree variable. We want our seconds degree variable to be increased by 6 for every 1 second. So let's add it in our function and add 6 to it. Now let's check our seconds degree output. So our output just printed for one time because we didn't set our second completed to false. So let's just add second completed to false at the end of our function. So now we can see our output is printed for every 1 second and our degree is getting changed by 6. So as we can see, our degree is getting beyond 360. So let's add an if statement. If seconds degree is greater than or equal to 360, Then we'll set our seconds degree to 0. Let's decrease the timer so that we can see the output quickly. Okay, so now as soon as our seconds degree is greater than 360 or equal to 360, it is getting started directly from 0. So now it's working fine. Now let's change our timer back to 1 second. So now this is the logic for our seconds hand. Now set seconds hand dot rotation dot y is equal to dig to rad and add our seconds degree in it. So now we can see our seconds hand is rotating, but it is rotating at a wrong direction. So let's change that. Add a minus to our dig to rad method. So now it is rotating correctly. Now for our minute hand, let's create a minute degree variable. So for our minute degree, divide 360 degree by 60 minutes and it will be divided by 60 seconds as we want the minute degree in seconds. So our minute hand will rotate 0.1 degree for every 1 second. So let's increase our minute degree by 0.1 for every 1 second. And let's check our minute degree output. Also add minute hand rotation to it. So as we can see, our minute hand is rotating for 0.1 degree for every 1 second. But as the rotation is very minimal, we can barely see it. So to check that, let's set our timer to 0.1 second. So now we can see our minute hand rotation. Let's create an R degree variable. And calculate an R degree for every 1 second. So 360 degree divided by 12 hours, that will be divided by 60 minutes and it will be divided by 60 seconds. So we can see that our R and will be rotating for 0.00833 degrees for every 1 second. So let's increase our R degree by this number for every 1 second. I am taking the complete number, but you can take till 0.083. It will still work. Now let's add the R hand rotation. Now let's check the R degree output. We can see the R degree is increasing, but cannot see any difference in the rotation. Also set limit to both the degrees so that they will not go beyond 360 degrees. If it is beyond 360, then we will change it back to 0. Let's change the timer so that we can see the R and rotation. Now we can see the R and rotating, and when the minute hand completes one loop, an R will be completed. So now so far our logic is completed mostly. But still we cannot set a time manually. So let's create that. We will create 3 export variables for hour, minute and second so that we can take input directly from the inspector. For now, let's set the hour to 3, minute to 15 and seconds to 30. So now let's call our ready function. Let's add hour and rotation. But first comment out the process and increase second just for now and take a look at our ready function. So 360 degrees will be divided by 12 hours. So it will be 30 degrees which will be multiplied by the hour variable. Let's do the same for our minute hand and second hand. So now in the output we can see the initial position of our hands which we have set through the inspector. Now let's uncomment this. So now even if we set our initial position through the inspector, it will still not work. So in order to solve this, we will have to convert our input to degrees and add that degrees to our hour, minute and seconds degree, which will then be taken through the process function. So let's create a function called calculate hour degree, which will take two variables, current hour and current minute, and it will return a float. That will be our degree, which will then be added to our hour degree. So it will return current hour multiplied by 360 degree divided by 12 hours. Let's just set it directly to 30. So this will calculate our degree in hour. Then add current minute divided by 60, which will be multiplied by 30 degrees. So the second part will calculate the degrees in minutes. So now our initial R degree will be stored in our R degree variable. And let's add that degree to our R and rotation. Now let's check the output. So now our R and degree is set to 1 hour, 15 minutes, 30 seconds. Let's comment the process and increase second function one more time. And let's change the R to 5. Let's change it to 12 or 10. So we can see the R and is set to 10 hour 15 minutes. Let's change it to 9 hour 15 minutes. So it is working correctly. Now let's calculate our minute degree by creating one more function named calculate minute degree by taking two inputs, minute and seconds. Let's create a calculate minute degree function with current minute and current seconds input. So it will return current minute multiplied by 360 degrees divided by 60 minutes, or current minute multiplied by 6 degrees. In addition to current seconds divided by 60 seconds multiplied by 6 degrees. Now let's add the minute degree to our minute hand rotation. So in the output we can see all the hands are working correctly. So for our seconds degree, 360 divided by 60 seconds, that will be multiplied by the seconds input. Or we can directly take 6 degrees into seconds and add the seconds degree to our second hand rotation. So now our seconds hand is working correctly. Let's just uncomment the rest of the code. So now we can see a fully functional analog clock which can be set manually. So I hope this video was helpful.